All right, we're gonna do another problem here with scatter plots and lines of fit and using those as predictive models. All right, so for this problem right here, it says we're dealing with Old Faithful, and what they're saying is the time of the next eruption of Old Faithful is predicted by using the duration of the current eruption. So if you know the length of the eruption that's happened, then they put it into this prediction model, right? This number, this equation that helps them to determine how long until the next eruption. And the reason this is useful is if you've ever been to Yellowstone Park and ever been to Old Faithful, it is a very tourist-driven thing, and people like to know, oh, at what time is this happening, so that they can show up for it, right? So it's good if you can say, well, the next eruption is going to be in 50 minutes and it winds up taking an hour and a half. You're going to lose people, and people will not buy as many, souvenirs and blah blah blah. And so it's all about money basically, but it's also about just being accurate. So they came up with this predictive model, probably from years of taking statistics on it and trying to find the correlation between it, right? And that's where statistics is really valuable. So when they say in letter A, find the independent and the dependent variable, all right, well, it tells us in the problem, it says the next eruption can be predicted by using the duration of the current eruption. In other words, if you know the duration, you can find the time, all right, the time to the next, in other words, the interval of time. So if you know x, you can find y. So that's a good way to think about this one. So x is your duration and y is your interval. All right, so we found that. So our independent is x, that's your duration. Your dependent is y, that's your interval. So we're going to go down here and we're going to call, this is going to be our duration. It's going to be this one right here. And then our interval is going to be right here. Okay, so let's go back up now, and we're going to make a scatter plot, all right? So if I look at the values of my numbers, my duration goes all the way up to 5, my interval goes to 100. All right, so what I'll do for this is we'll make duration can go, we'll say this is 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, right? This is 0 minutes. And then interval, I believe it went up to 100, right? Yeah, 100 minutes in between. So we'll just do 10, 20, and then we'll go up 40, 60, 80, and 100. And then we'll take this data, right, and we'll plot our points with it. And so the way we're going to do this is I'm going to write these as ordered pairs. So I'm going to go 1.5, oops, and 48, 2 and 55, 2.5 and 70, 3, 72, 3.5, 74. And I'm writing these as ordered pairs so that I can plot them. Right? And I know what's x, I know what's y. 482, 4.5, 93, and it looks like we have 8 sets of points here. Now I'm going to use this neat little tool I can use here, and I'm going to cut this, and then we will go like that and paste. All right, and now I'm going to plot these points. I'm going to move this up here. All right, we'll leave those there. So let's plot our points. So 1.5 is going to put me right here, and I'm going to go up to 48. So that's going to put me right here. So there's my first point. 2 is going to put me at 55. So that puts me right here, right? Because each one for my y is 10, right? 2.5 puts me at 70, puts me right there. 3 puts me at 72, so that's just a little bit right there. 3.5 puts me at 74, so a little higher. 4 puts me at 82. A little bit more of a jump that time. 4.5 puts me at 93. It's a more significant jump. And then 5 puts me at 100. So it puts me right there on the crosshairs. All right, so I have all my points listed now. And so what I'm going to do is I'm going to make this into red, and I'm going to draw a line of fit and see if I can find something that works for all of this. So when you draw a line of fit for this, it'd be nice if you could include some of the points. So I think I'm going to do this. I'm going to hit the snip tool here. I'm going to move this down about right here and put that there. And we'll take this and we'll move this up here a little bit. And then I think that's a pretty good, line. All right, I think we like that. Okay, now you'll notice that on this line, okay, I have 2 points that fall on the line. I've got this point and this point. So we're going to use those 2 points now to find our slope. Because remember we determined that if we can find our slope, then we can use y equals mx plus b to figure everything else out. So we're going to use these 2 points to find our slope. So you do your change in y. Well, change in y is just subtract your y coordinates over your change in x, which is 5 minus 4.5. So you get 7 over 0.5, which is 14. All right, because it's 7 divided by 1/2. All right, and 1/2 goes into 7 14 times. Right, so you get 14 for your m. So if m is your slope, we're now going to put this in our all-purpose equation, our y equals mx plus b, with an easy to work with point. And so let's use this point right here. Let's use 5 100. You want to use a point that's on the line, right? So we'll go y, well y is 100, equals m is 14 because we just figured that out, times x, which is 5, plus b. All right, so you wind up getting 70 plus b equals 100. So that means b has to be 30, because if you subtract 70 from both sides, that's what you get. So now I have an equation. I have y equals 14x plus 30. I just took that m and that b and I plugged it in the equation, and away we go. All right. Now it asks us, all right, write this form of this equation and predict the interval after 7.5 minute eruption. So I'm going to use this equation now, and the duration of the eruption is your x variable, right? So that's going to go in there. So I'm going to put 7.5 in there and see how long we get. So you got 14 times 7.5 plus 30. Well, 14 times 8, all right, gives me 112, and 14 times 7 gives me 98. So halfway between that, I would just add 7 to 98, right, because there's 14 between them. So add 7 to 98, and that gives you 105. And I find that easier than doing the traditional algorithm with a decimal. 105 plus 30. So they're saying that there will be 135 minutes between after a 7.5 minute eruption. That there will be 135 minutes till the next eruption. So that's 2 hours and 15 minutes. So that would be good to know, because that's a long time to wait. And people can, maybe hang out there and eat food and spend money at the gift shop and do all that things. And so they might actually like that there. So that's this problem. I hope this is helpful to you, and good luck with these.